Hello my friends, and welcome to Inside Out Learning channel. This is Uncle Misha. And today we have Sony linear tracking quartz lock direct drive fully automatic stereo turntable system PS-FL7 on our bench. This thing needs some attention. It's a little bit broken-ish. And honestly, I don't even know what is the problem with it. It has a little bit of cosmetic issues. So it's top a bit scratched up. This is broken. This is scratched up. But overall, I think it's more or less okay. So let's look what do we have. So this is turntable, but this guy is drawer style turntable. So instead of opening the top and putting the record on top of it, it actually slides out, and you can put the record right in it when it slides out and press the button. It slides in and continues playing. And also it is linear tracking. I'll show you what I mean. So controls. I have two speeds, 45 and 33. It has repeat. I'm not sure what really that means. I assume it repeats the whole side. It can manually move the arm. I'll show you what I mean. And there is a button start and stop and open and close. There is a power button right here. On the back, there is nothing really interesting except just RCA pigtail and power cord. Okay, so let's power this up and see if this thing is actually working or not. Have this nice button right here. And I think we see a little LED right there. But so next step would be press open and close button. And here we are. This is pretty much, I'm sure it's very slow. Whoa, what's happening? So we have this platter show up, and that's where I think you put your record. And then next step, next thing, important thing is this, how do you call it? Tone arm. But as you see, it's very interesting. Not sure if it's gonna move or not, but it moves not instead of moving like this, for example, like any conventional arm move across the disc. This one moves like that. So that's why it's called linear tracking. If you look at this, how do you call the platter mat? It's actually seen better days. Looks like it's sort of kind of shrunk a bit. I think. I don't know, a bit dirty here. So yeah, I need to someone try to lubricate it or something. So you definitely need to pay close attention to what's going on in this guy. I have no idea if it's will be operating. Let me find a record and let's give it a try. Well, I think this Barbara Streisand greatest hits volume 2 is the good test candidate here. Wow. Haven't obviously. All right, let's close it. Oh, I see I pressed the start and it just decided to close on its own. So it's smart. And it is not spinning. Clearly we have a problem. All right. So the thing is not spinning. So now we have to clearly, but by the way, let me lower the camera. I'll show you something. Or you probably see it, I don't know. Oh, it's spinning. What? Just started spinning. Look at this. See the slides moving? I actually manually moving the tone arm. Okay, so certainly I don't know how to operate this device because there is a button speed repeat arm lifter. Let me try do some arm lifting or arm. Oh yeah, I saw it actually push down. Oh wow. I would expect. I don't understand the stop button. I was thinking. Okay, I moved it all the way that way. Now let me try start. Okay, started rotating, and it moves. It moves, but it doesn't. And stopped. Moves back. And stops. It moves back in. But for some reason, it's not um, not not dropping the arm. It just like hangs there. But now, in some random place, I can drop. So yeah. Okay, I just hooked up the amplifier and the speakers because I don't have it ready. And let me. I really probably need to press start. Move a little bit tone arm over somewhere over the surface of the disc or the record and just hit it. Yeah, it clearly works. All right, so that's good news. So we have working cartridge, we have working tone arm, we have working motor which actually spins all this stuff, and the working motor which actually moves the tone arm back and forth. We have working motor which actually opens and closes. As you see, it's super filthy, but it's a different problem. Also, I don't understand if this mat is good, because it looks like it's kind of shrunk. It doesn't really sit well. But nevertheless, maybe this is the problem, why it's not detecting it. But it's actually, in general, it's good news. So, but still, we probably need to calibrate, clean, and lubricate this thing. And also, we always interested to see what's inside. So guys, let's dive in together. So guys, let's dive in together and see what's inside.
Okay, so here we are. So we brought our PS-FL7 to the bench. Now we're gonna try to understand. Actually, you're probably gonna just try to open it up and see what is the problem. Okay, so it has few screws on the perimeter right here. I'm gonna just open. We'll be very curious to see what's going on inside. Four nice screws. Is any screw here? No. Oh, very easy. What is that? It's like a power button connector. There are two possibilities. I'm just probably gonna unscrew the whole power button assembly. Alright, so power button assembly is out. Cases actually turn out to be, top is plastic. Okay, here's something broken, but we probably can fix that. Very dirty inside. This is the platter. Looks like there is some kind of optical contraption right here. This is power supply. We know that actually power is working, so I assume there's not going to be a problem. Okay, so there is a wire which actually drives this pickup. Okay, I don't know why this is shaved. So let's try to power up this guy. I'm curious. Oh. Okay. This is actually Ultraphone pickup. That's cool. Ultraphone pickup. Nice. Not sure what the condition is. So it'd be nice to kind of maybe unscrew it and take a look at the condition of the TM7, Ultraphone TM7. Again, I'm not a big expert here. Never actually had the chance to play with Ultraphone. But let me power this guy up and we will see. Power button. Speed selection is working. These buttons are working, yeah, so. Not sure if this is normal speed, but it actually goes pretty slow. This is the rail, it's the ride zone. Yeah, well, I mean, at least this sort of operation is all right. Okay, let me put a disk or LP and we will go from here. I'm curious if there is a, you see there is a LED here, or two LEDs. So supposedly over here, straight under this device, supposed to be two sensors, which actually sensing the size of the record. Unfortunately, I don't have any small records, but I definitely have standard records. Okay, let me use this romantic guitar record. And just go. And well, I mean, it does play. Actually, I hear it. I hear it from the vibration from the stylus. I don't even have to. Yeah, it does play. Wait, what was the problem? It goes faster. Goes slower. Stop. There is no pause. There's no pause when it just stays where it is. Let's do again. I don't know why it takes so long to kick in. Let me try to show you something. Okay, I was open. Let's close it again. And start. Pay attention. Maybe not happen. Not happening. The last time I've tried that, this thing kind of jerked and couldn't continue. Oh, yeah, you see that? It's trying. All right. So the only one way to understand what's really happening is to take it apart. But like, oh man, this is not. I'm not even sure where to start here, but let me think about it. All right, I have some development. Turned out to be from the top is not the right way of approaching this thing. Yes, if you need to work on rollers and other things, maybe yes. If something broken here and stuff, yes. But there is a better way of approaching this guy, and we're gonna do this together. So it turned out to be, I learned that you can actually open the bottom of this thing. So I did the jump cut. I actually assembled everything back how it's supposed to be. Everything is operating, but we have to access it from the bottom. Let me turn this. It's actually quite heavy, you know, for this sort of operations. From the bottom, and bottom has a whole bunch of screws on the perimeter here, so we can remove all that. Let me quickly do it off camera. All right. So after removing 9 screws and 2 missing right here, so it was 3 here, 3 here, and 3 here, and 2 screws probably permanently missing because someone was in there So we are going this way. Okay, so this our cogged rail, so that's gonna be put to the side. Obviously the bottom plate already removed in the previous video, so now we have nice access to hold this, all this stuff and all this moving obviously freely, because there is no, hope these wires are okay, not gonna damage them, because there is nothing, there is no rail which actually it's rolls, this gear rolls on. So now it's just like, I don't know why it's stopping here. Yeah, not gonna figure this out. Well, anyways, so it just stops. Okay, so what I was doing also as well on the top, so in order to this thing to operate, you have to make this switch be pressed, because there is also two stoppers here and here. When in this position, it engages and the system knows it's closed, and in this position it fully knows it's fully open. So you have to do something. In this case, I'm just using this dinky wire, or you can use pretty much anything, or maybe even rubber band is better than dinky wire. Actually, just find a wide enough rubber band and make sure it's gonna just but you know, like something like that. Hope it's like it's gonna stay like this. So this thing system gonna know that it's in closed position, doesn't matter what position it actually is. So now we have nice access to the motor, and I think we can take it out. Let's just take it out, and we're gonna be playing and measuring. You know what, before I take it out, because there is some voltages I would like to check right here. So there is a bunch of voltages in this area, so let me see what we get here. Let's power this guy up. Is it powered up? Really hard to see, obviously. No, it isn't. Probably because I didn't turn it on here. How about now? How about yes? So it's powered up. So right, this gentleman is powered up. Let's check some voltages, because the power rails is very important. So we have some power rails here. We have a ground. It'll be easier. Now we have plus 15 volt. It reads 14.4, and is it drifting? I think it's okay. Then we have minus 6 volt, minus 5.7, and then we have plus 6 volt, 5.7. I'm wondering where is this, yeah, it is. So it's not marked. So there is a ground minus 15, which is 14 something. 14.9, that's good. Then plus 15, which is for whatever reason 14.4. Then we have minus 6 and plus 6. So it's like 15 plus minus, 6 plus minus. So I'm not sure why 6 volt and why 15. 15 probably for op amps, 6 volts probably for logic. I don't know. Let me see. Ground. I don't know. There's some ICs here, but I'm not sure where would I. Yeah, actually. -5.7, -5. Yeah, so the same voltages are coming also to this board. So this is like a logic board. This is like motor driver board, which is pretty intense for what it is. I thought it's going to be a bit simpler, because some other boards I saw a bit simpler, but this one has 1, 2, 3 IC. So, and it has here a driver, and it has 245.76 kilohertz. There is a quartz resonator right there, and this resonator probably a 2045.76 kilohertz. Yeah. All right. So let me remove this thingy. So voltages seems to be in okay. Well, I don't like they are a little bit lower. Maybe this is the problem. Maybe something is kind of loading the circuit. All right, but for now it's within the tolerable range, I think. All right, so let's just shut it down and unscrew. Okay, I have removed all 5 screws. Now just gently lift the motor and I try to spin it around. I think maybe better this way. Yeah, it's better this way. Is it? Oh, no. This more one. It's a grounding thing. Okay, and remove this grounding screw. Now we can spin it around. No, better this way. Okay. So here we have it. So as you see, there is like 1, 2, 3 ICs. I mean, I assume this one is motor driver. Yeah, I need to find good schematic. I'm not sure. Those two like op amps or something, or comparators. So yeah, gonna get schematic and gonna double check everything. Also, I would like to double check those capacitors, how good they are, if they're in good shape. So yeah, I'm not sure the purpose, because some of them should be just filtering capacitors, but yeah. Oh, this is interesting. This is supposed to be a fusible resistor. Cool, 2 fusible resistors, because it says R, but there is a fusible sign to it. Very interesting. Okay, the 2 transistors, I assume those are driving transistors to drive coils, and coils, as you saw, the little tiny wires that are on the side of this are for to drive coils, and there are 2 coils, so 2 pairs, probably 2 and 2. I assume they like that arranged, or something to this extent, like a cross. So 2 connected to 1. This is 1 coil essentially, and 2 sides connected to other coil driver, transistor driver. So also there is this PCB which has this like a trace which zigzag every across or around. So I assume this is speed control. I'm not sure how that works, but probably through the induction, and higher the speed, probably the higher the current flowing, and this is how they sense induction. So very, very interesting how that works. So we have to read up about that, but this is my like educated guess. Okay, so we don't have anything shorting. Let's just power this guy up and see if it's gonna be spinning. If I press start. Okay, looks, this guy is going. It's probably just moving a moving tone arm. Yeah, nothing really happening. Sometimes it's actually starts spinning, but like... Okay, so I got nothing. It's not spinning at all. So maybe I even messed it up. I hope I didn't. Let me shut down everything and try to measure some capacitors here. Who knows? Maybe electrolytics are gone, but they looked okay. So we have only like several of them, not that many. So we can check. This guy probably very okay. Well, at least from the first glance, because it could be some other problems. Maybe it capacitance is, sorry, it's not completely busted, but capacitance is wrong. Okay, there is more. One more here. ESR seems to be okay. There are 2 more here. Yeah, I don't know what's the value, but seems to be okay. For the small capacitors, 3 ohms ESR is actually okay. I'll need to see what the value is. Okay, this capacitor is good. It's 1 ohm. Actually, it's pretty good for what it is. This is good too. I don't really remember everything. Okay, there's teeny tiny one here. What do we have? Whoa, whoa, whoa. That's interesting. Let me try again. Okay, this is good. 1, 2, 3, 4, 5. I think I measured this one already. 6. 7. This is very low for this tiny capacitor. Let me double check. We tested that. Let me double check. How did we test this tiny one? 1 ohm, 0.83. Wow, surprising, but okay. The reason I say surprising because this little gentleman here is 1 microfarad. Usually 1 microfarad 50 volt is higher than that. So we need to maybe double check these guys. Who knows, maybe they're bad. Okay, I don't think I see any more electrolytics. So let me count them again. I got sidetracked. 1, 2, 3, 4, 5, 6, 7. 7 capacitors. Okay, so we have 7 electrolytics. Let me turn this board around and I double check if I missed something. Oops, that was paper towel. One, 2, 3, 4, 5, 6, 7. 7 capacitors. Okay, capacitors seems to be okay, except those teeny tiny guys are slightly suspicious because super low ESR. So I decided to use soldering braid because my desoldering gun migrated to different workbench and I don't have it here handy. Well, if there's gonna be more desoldering job, obviously I would bring it back. But for now, as a quick 2 capacitor thing, I can just use that, and it's handy. A little bit here. This is falling down. Let me take those 2 gentlemen here. 1 microfarad 50 volt, that's what I thought. Okay, we can do a few things. Let's just put them here. We can test them with multimeter. And then, I'm not sure if I have to use component tester, I need to find it. Capacitance. Okay, that was unfortunate. Huh. Well, I mean, it's good. So maybe I was wrong. And then the another guy, where are you? If this one does not want to cooperate. Yep, 1 microfarad, all good. So I was wrong. So obviously this is like shut this down. Let me get my component tester. I want to see the more parameters. Maybe I should have tried it at first. Okay, yeah, ESR is 6.5, which is more like it's supposed to be. Yeah, let's try another guy. Just put it here. Yep, the capacitors are good. Alright, my bad. Wanna put them back. So, there's obviously something else. Well, let me think what it possibly could be, but for now, I have to go back to work. Alright, my friends, so I was doing a lot of investigation off camera because I didn't really know where it's all going. So, what do we have? Okay, let's It's not good. It looks like it's shorting here or something. So this point is the ground, by the way, so I was measuring it. Okay. So where we are, so first of all, I can tell you that there is a signal. So there is a quartz resonator right here, and there is a signal. Okay. I don't know why it's wibbly wobbly, but it is there. Let's do measure. We have 7.8 megahertz. Oh, because I didn't connect ground properly. Okay, let's try again. Like here, or like. Here we are. Oh, that's much nicer signal, right? Beautiful. Beautiful, sinusoidal. Very nice. Yep. Alright, this is looking good. But now, when I go here, after divider, look at this shit. Huh. It's actually nicer. Interesting. That's how it's, yeah, that's nicer. Alright, so take a look at what I found. Okay, this pin looks like this. So this is signal is 71 Hertz. But when I switch speed, it becomes 95 Hertz. Very interesting. So clearly it reacts to speed changes. So what I've done here, in order to investigate what is happening, I have disconnected two resistors which connect this servo IC in this area with the rest of the circuit. What servo IC does, it actually has the feedback by this like a coil, which actually on PCB right here, and based on this feedback it regulates motor driver. Right now this is disconnected, and what I see that sometimes this thing spins randomly. Okay, I would suspect it would go full tilt if this is disconnected, but it spins randomly. Okay, right now it's just jerked, now it jerked again. So there's something wrong here. So this probably some kind of voltages, floating voltages on the level, oh sorry, on those pins, causing this thing to go, you know, go wild. That's only my explanation. Or we have problem with one of those Hall sensors, they are faulty. I don't know what else to say. Also, what I've done, I check coils, they are fine, they're 82 ohms each, so they are not broken, so coils are fine. I don't know how to check Hall sensors because they are literally somewhere under here. In order to get to them, have to kind of take this thing apart. Probably I'm gonna do this because I have to understand if Hall sensors are working. Obviously the motor driver can be Gonski as well. I'm not sure how would I check that. Yeah, but also I checked level right here on I was just poking around hoping that it's gonna trigger some kind of rotation, but no. Level on those resistors, I can show you with multimeter. Okay, so those potentiometers right here, they are this offset is connected with the output of a Hall sensor. So it's like, you see it jumping, I'm not sure why it's jumping, and here it is less jumpy, but jumpy as well. That's surprising, because I mean I didn't expect to be jumpy. That Hall sensor they fed through those two dividers called gain and through transistor Q104. Q104, and we have a meter. Let's see what we have on here. All right, so we have 4.5 volts almost all the time, and collector has to be 5.6, which is 5. Base is driven by the op amp, which is driven by this servo. Okay, but the servo is disconnected right now. An op amp on output, which is number 7. Where is 7? 7 is always 5.2 volt, but it's supposed to be depending on the speed. But it's high because it disconnected from this guy, and this guy actually right now the output is 7 and 8. They are nothing because there is no rotation, right? Now let's wait before this thing starts rotating. It randomly jerks. You have to start it. If you start it, there is something. Here we are. Now I forgot to start this because this is the only guy who receives start command. You see that? It changes, and this thing is slightly rotating. So I'm waiting for this thing to kick in. Hello? Okay. You see that? So essentially what's happening, when it reaches higher speed than needed, it drops. Okay, rotating again and stops. Now I can manually rotate it, you would see that. Obviously I cannot constantly rotate it, but you got the point, right? Essentially. So this is how servo works. It regulates the speed of rotation. So essentially I think that part is working. The servo, I think it is working. What's not, I cannot understand. It's either something wrong with this op amp, but part of it is working because one part of it is used in conjunction with this servo. Another part is amplifies the servo signal through this transistor, well, and some other in these transistors, and sends it to where? Sends it through this transistor to both hall sensors through these voltage dividers. Okay, so let's see. Okay, what is this? I don't know. That's another transistor, so it's a voltage, and resistor, I mean to say. Okay, so here's the gain. So these two gain resistors, they are being fed by this signal, which is coming from. Nope, that's correct. Here. Interesting. Oh no, this is jumper. Okay, this is jumper. Where it's going? So okay, it's. Am I crazy? It's going somewhere there, so it probably goes all the way to this transistor. Yeah. 4.5, and here is jumper 4.5. Okay, what's on the base here? Yep. Well, there is a problem with this transistor actually. because technically five. Okay, let's check the pin 5 of this op amp. 1, 2, 3, 4, 5. 1.1 volt. And pin 6. 3.4 volts. Yeah, this pin 5 is actually completely floating in the air. And it has voltage on it, so yeah, it's weird. Yep, it's nothing connected to anything. It connected to those two resistors which are disconnected, so why there is a voltage here, I do not understand. That's weird. I understand on 6 because it's also feedback, but not on 5. It's a good question. All right. There, I have to stop here, stop this debugging, because I'm actually start to go crazy a little bit, and I have to stop for now. I'm gonna stop this, and what I'm gonna do, I'm gonna try to reach those Hall sensors. Okay, I think, and I'm gonna try to see if I can find a replacement. But even this op amp is kind of weird. I'm not sure if this is what's supposed to be happening here. All right, so I'm trying to take this thing apart. So in order to take it apart, it's actually not as hard. This guy actually pulls out just like that. All right, look at this cool thing. It has some lubricant in here, and it has this ball, which obviously to reduce friction as much as possible. All right. Oh man, this has a retaining ring. How do I gonna do that? Huh. Hope it's not glued or anything. No, it's not. It's spinning. But something like that. Okay, it's out. Put it here. Okay, now we have to unscrew this guy right here. It's all start falling apart. Okay, now I have to be, I guess, super careful. So those three thingy would be disconnected just like so. Okay. Okay. Does it have to be like desoldered or what? I think it can be just bent. Alright, so here we are. The beauty of induction motor here. Look at that. Okay, now how do I disconnect you? How do I do not damage anything? Alright, here we are, just like that. So those super teeny tiny wires, wow, it's everything now is big mass. Okay, this copper washer or bronze washer goes here as well. Now, in order to see, okay, so here are these Hall sensors. Again, I have no idea how to test them yet, at least. Now we have to like turn all this around carefully, not to yank any wires. And I'm gonna take a photo of them in order to understand what I'm looking for. Okay, this is super sketchy business here, because these wires are so tiny. Alright, so this is better. Alright, so here are the Hall sensors. They are, I have a name of these. Look at this, probably beefy. Oh, it's magnet or it's yeah, it is magnet. Not strong actually, but it is a magnet. Okay, Hall sensors. Let me see if there is no any kind of obvious problem there, like a corrosion or anything, but or bad contact. No, it seems everything seems to be all right. So yeah, we have to figure out if those Hall sensors are fine. That's the main question. I don't see any other damage or anything like that. So okay guys, so here's the photo of the Hall sensors up close. I think I would have to kind of stop at this. Probably gonna assemble it somehow back in the original shape, or maybe kind of assemble it just to keep it in place, because it's a lot of disassembly if I need to get there again. But at the same time, I don't want to leave it on my bench like that, because it takes some precious space and time. So if you have any ideas what could be possibly going on here, please tell me, because I'm kind of puzzled. I don't have enough expertise in this sort of area in order to understand why this is happening. Alright, I'll be obviously learning more about those motors and motor drivers. Obviously I don't have any spare parts, like spare drive, just to swap them out and see if, what's going on. So yeah, I believe could be Hall sensors, because I think they behave in like the levels when the similar levels of voltage supplied or to them on output, we get different values. So this could be an indication there is something wrong with Hall sensors. The problem is these guys are obsolete, so we have no idea if this is even possible to repair this stuff or find a suitable replacement. So probably gonna take some time, and thus I'm gonna stop now and continue in part 2. So guys, thank you for watching. Hope that was useful and interesting. If you wanna see more videos like this, please subscribe. Stay safe and ciao.